and 2 FADHs from the TCA/Krebs cycle. So all of those are coming over to this step called respiration. The molecule out is ATP. We get most of our ATP from this step. Because if you go back to everything on that side of the board, we made 2 little ATP right here in glycolysis, and we make 2 ATP in the TCA cycle, and that's all we've made so far. From 1 sugar is 4 little measly ATP. So we're going to get massive amounts, 32 to 34, out of this step as our molecule out. And they're going to be made by oxidative phosphorylation this time, not by breaking bonds like we've been doing here, but by using the energy from proton mode of force, having negative on one side, positive on the other. So everybody's copying, have time? Yes, sir.
Never mind.
Okay. So, the electron transport chain. Here's where we get to talk about how the one side of the membrane became negative and the other side became positive. Let me get rid of glycolysis and transition and Krebs here. All right. So, here's our membrane. We're talking about a bacteria. This is the cell membrane, right? We're talking about a eukaryotic cell. It's the inner membrane of the mitochondria, the one on the inside, that roughly one. The electron transport chain is a series of proteins embedded in that membrane. Electron transport chain, series of proteins embedded in the membrane. And what it's going to do, we use it to generate that proton motive force. So all of the NADHs and all of the FADHs that we've collected in the previous steps are bringing their electrons over to this membrane.
This is the
Integral?
mitochondria.
For eukaryotes, it's the inner membrane of mitochondria. For bacteria, it's the cell membrane.
Okay, that's only for bacteria, integral, okay.
Yep. Cell membrane, bacteria only. Remember, eukaryotes don't do this on their cell membrane.
So would you say that the NADH and FADH are bringing their electrons towards the electron transport chain? Is there some reason why they're particularly attracted to those? I just noted over. I don't know.
Yeah, I mean, I don't know that anybody knows the details of that. I don't think that there's like a magnetic attraction where they get sucked over.
Okay,
But
they just kind of
it's
migrate.
their
up.
job, yeah, they kind of migrate over.
Okay.
So these NADHs and FADHs are going to give those electrons that they took from the food to this first protein in the electron transport chain. So are they still NADHs after they've given up their electrons? No. What are they now? NAD plus and FAD plus.
Okay.
They're back to being oxidized. Now remember, that electron didn't happen by itself. That hydrogen has an electron and a proton. But this is the electron transport chain, so we're following the electrons. That electron is going to be passed from one member of the electron transport chain to the next. They're playing catch with it. And then it gets passed to the next member, and passed to the next member. Those proteins are passing the electron down.
Okay.
As that electron gets passed or falls down the electron transport chain, that proton that came with it gets pumped across the membrane. And remember, we didn't just have one NADH, we had 10 of them, right? 2 from glycolysis, 2 from the transition step, 6 from the Krebs cycle. So we have 10 electrons that are going to fall down and 10 protons that get pumped out. We had 2 FADHs that are going to do the same thing. Electrons are going to fall, protons are going to get pumped out. Yes, sir?
No, I'm just looking,
Yeah.
I'm sorry.
All right, so that's going to happen 12 times, right? 10 NADHs, 2 FADHs. So eventually, we're going to have a lot of positive charges on this side of the membrane from those protons. And the electrons are falling just on this side of the membrane. So this side's negative from the electrons. The other side's positive. That's our proton motive force. the electron transport chain generates that separation of charges we call proton motive force. And again, if we come back over here to the pictures, in eukaryotic cells, this electron transport chain is right here in the inner membrane of the mitochondria.
Okay.
So those positive charges are in this space between the two membranes, and the negative charges are in there. Right? So we're talking about positives and negatives. Bacteria, these electron transport chain is in the cell membrane. So the positive charges are outside the cell. The negative charges are inside because that's the only membrane they have, is their cell membrane. They don't have any other compartments. So that location difference is really important. Questions on that?
I have a question. Okay, so NADH goes down through the proteins on the cell membrane of mitochondria.
NADH doesn't move. NADH gives its electrons.
Oh, gives the
And
electron.
the electron moves.
Okay, and then the FADH goes through,
Same
puts the
thing.
positive charges.
The FADH has given up its electrons. The electrons fall, and they go back to being NAD plus and FAD plus.
So it gives up the electron.
Other questions? Okay, so far all we've done is create proton motive force. Picture from your book, we kind of made the electron transport chain look like stairs. The electron is falling down the
Proton
stairs.
cross electron down.
Proton
We give
gets
up the
pumped out.
Okay.
The electron has to go somewhere, right? Eventually it reaches, yeah, I know. Oh, we have like 1 minute. Okay, eventually it reaches the end of the electron transport chain. Where it's gonna go is to oxygen. That's the terminal electron acceptor. We're gonna have to stop there. I've got your test and your homework to give you. And so if you came in late,